Okay, we're up to example 27, and we're still in section 3.2, and we're in, this is about the derivative as a function. This is just a simple visual example for you. There's no work here. I just wanted to show you examples of points where a function does not have a derivative. So in general, what you have to remember is that the derivative of any function is a limiting value of the slope of secant lines. So as you have secant lines, you want to squeeze the points closer and closer together until you actually have a tangent line at one point. Okay, so it's actually a limiting value. So the problem is whenever you have like a corner, a sharp turn in a function, the secant lines look like they're trying to approach, as I come into this from the left side, the secant lines look like they're trying to approach this value. But as I come in from the right side, the secant lines look like they're trying to approach this value. So sharp corners on a function will not have a derivative. Likewise, a function like this does not have a derivative because these secant lines do not start to approach the same value. Actually, they do, but they start to approach infinity. So a slope of infinity or a vertical slope is not, there's no such thing. This is called a cusp, okay? And then here's another example of where you get an infinite type of a slope where the secant lines start to approach a slope of infinity. That will not have a derivative. All right, here's what's called a jump discontinuity, where I jump from here up to here. So these do not have a derivative either. And this is a whole discontinuity. So these guys will not have a derivative because it looks like I'm trying to, tangent lines don't look anything like something down here. So these are examples of functions that don't have derivatives. What I want you to remember is that if I have a sharp corner or a cusp or an infinite slope or any kind of discontinuity, then the function cannot have a derivative at that point.